to sharing screen. Back to go. All right, so let's start with our review. Let me
showing
just
your screen.
Oops, what? I'm not sharing screen. Oh, yep. Thank you. Okay, so let's talk. Let's talk about our schedule. On Tuesday, I will be around to answer questions. But that's the Tuesday before Thanksgiving. So then you have Thanksgiving off. So I fully expect that a bunch of you will not be here on Tuesday. I'm not taking attendance on Tuesday. So if you have some Thanksgiving engagement or whatever, don't bother. You don't have to tell me. I will really start a robust review of all the material starting the first week in December. When we come back, let me just show you the schedule here if I can. So Thanksgiving, so Tuesday's the 26th. That again, I'm not taking attendance. Then the 28th is Thanksgiving. Then let's just put this into, you have review on the 3rd, the 5th, the 10th. And then the 12th is when your final is. So we only have 3 classes afterwards. So if you need help with something or you're falling behind, whatever, then come on Tuesday, come on Zoom, ask some questions if you need any help. That's fine. I think the 11th is when things are due. The 12th is the final, but the 11th is when your project is due officially. But yeah, it should have said the 10th, but the 11th is when it has to be finalized. There's things you have to do with the project. I don't know. I sent out a thing about the project, and you have to get people to review your project. In other words, they just have to look at the worksheet and see if you're saying things that are interesting and relevant and informative. You don't have to ask AI to generate an analysis of somebody's worksheet. All you're there to do is look at it. And if they're, if they're predicting the price of tea 10 years ago, then tell them maybe next year's a better year to predict the price of tea. Think about what would be interesting for you to know and let them know that so they can do a better job of doing their presentation. So that's what you're trying to do. All right, this is your class. No, this is not your class. Fine. So let me just open up mod 11, 12, and 13, just so you know. Oops, where's that stuff that I just said? Here's the project information. As I said, the most important thing is that it has a you have to, not the most important thing, but the only thing I didn't mention to you earlier is that you have to review 2 people and you have to be reviewed by 2 people. All right, sorry about that. Lessons, mod 10. All right, so let's just take a look at quiz 10. Oops, sorry. The item analysis. Let's see how you're doing with quiz 10 so I can finish up the last of the material. So this is the last of the material that you have to know before the final. And then, as I said, the rest of the course is review for that. Also, today is the last day. Only 7 people did this quiz. That's too bad. After today, it's due tonight, but after tonight, I'm closing this quiz. I'm closing all quizzes. I'm carving your grade in stone, and then I'm opening up all quizzes. So they'll be able to work on the quizzes for practice for the final, but it won't affect your grade any. Okay. Sorry, but I want you to be able to do those quizzes, but I can't open them up without doing that. So that's what we're going to do. Okay. Any questions so far? Are we good? Jonathan, Alicia, Acacia, Eric, Luke?
Yeah, I'm good.
Okay, good. All right, so let's look at the first question. This is line 20 from here. So what's happening here in line 20? Okay, so from line 20 to 21, what happened? So there's the integral, and they decided on a substitution u. And so what did they do in line 21? Anyone? What do you think happened? Here's u equals cosine. What does du equals minus sine dx mean? What did they do to get from that line to that line? From 20 to 21. Anyone? Luke? Talk to me. What did they do?
They substituted it.
They didn't substitute. They actually completely ignored the integral. So we haven't done anything with that integral. All we're looking at, that's all we're looking at. What did they do to go from the first step to the second step?
Took the derivative.
That's it. To find what? What is du called? It has a name.
I don't know.
Anyone know? It has like, it doesn't have, it has the word, it starts with diff, D-I-F-F. It has a name. All right.
Differential.
That's it. So all they did was find the differential in a substitution. They didn't do the substitution. They didn't do the integral. They just found the differential. That's it. Okay. Any questions on that? Thank you, Luke. Okay. All right. So this one is a presentation one. Who's going to help me with this one? Acacia, you want to help me with this one? She's like, don't make me help you. Okay. Here we are in a spreadsheet. I see this is the number of calculus graduates after 2000, and it starts with 0. So 0 means 2005 means 2005, and so on. Then here's a quartic regression. There's a quartic, there it is as a function. That f must be the antiderivative. Or no. Oh, no, that's just that with numbers. Oh, we don't even know what that is. Oh, but now capital F must be the antiderivative. And capital F evaluated at the two endpoints, that must be the what? What do you think that is? Capital F, the antiderivative evaluated at two endpoints is another way of saying something. Some theorem that's important or fundamental. What do you think, Acacia? Do you remember what that capital F is for? Fundamental theorem.
The antiderivative.
It is the antiderivative, but when you subtract it, evaluated the two endpoints, that's the thing that, remember that the integral of x, remember this, and then you had a1, b1. Equal to capital F of, does anyone remember what this is? It's a theorem. It's an important theorem. It's so important. It's the most fundamental theorem in calculus. Does anyone know what it is?
Did you say it?
Well, say it for me. Say it the right way.
The fundamental theorem.
That's the fundamental theorem of calculus. Thank you. So that right there is just, that must be 8944, must be this integral. This is a definite integral, which is what? What does a definite integral tell you? What's the definite integral tell you?
And it could be 120.
But what does the definite integral tell you? What is it?
You forgot the 0 in 12. It should be 120, not a 12.
Oh, we're not, Eric, you're ahead of us now. But yes. What does it tell you? It tells you the area under a curve, right? Do you see that picture? That's what it's telling you from 0 to 20. We don't want 0 to 20 though. They say use the regression and the approximate area evaluated 12 times to estimate how many graduates there are in the 10 years after 2005. I have to change something here. What do I have to change, Eric? You were about to tell me. I have to change n to be 120. Okay, that gives me an answer that's close. That's not the right answer though. Because you did definitely give me 120 rectangles and it is close, but they want it for the 10 years after 2005. So what do they want? Do they want 0 to 2020 or what? What do I change, Acacia? I have to change something to be 2005. Which one is the thing? I want to change to 2005 or something like
About
5.
it should be 5 and B1 should be 15.
A1 should be 5 and B1 should be 15. That's what we're talking about, that area there. And you see, that's a much smaller number, 2,680. But the approximate is 2,670. Okay. That's not too bad of an error. Okay, so 2,670 is the answer. There we go, 2,670. Okay. Thank you, Eric. Thank you, Acacia. Let's move on to the next one. Same thing, except this one is, don't look at the answer, don't look at the answer. Copy graduates. What do they want? So now I'm just going to skip all the niceties and give the answer. So the niceties are this: use the regression to approximate the area evaluated 12. So what do I have to change? 10 years after 2010, what do I have to change?
The 0 A1 should be 10 and we should keep the B1. We should keep B1.
Keep the B1, change that one to 10. That's the 10 years. And then what else? Where's the
You should put in the 0 in the 12. So it should be 120.
could be 120. 5816. Is that the answer? Yes. 5816. Okay. Next one. And that problem has a mistake in it. That's the answer to 5816 is correct. Okay, here's another one. Same thing. This is fine now. I'm not going to do another one. Okay, so evaluate this. Well, there's answers there. There's only 4 answers. Evaluate the integral of secant squared sine of tangent of x dx. Okay, so let's go to Desmos. Not that Desmos. Desmos that I have open. All right, hold on, I'll do this one. Okay, so they want the integral, the secant squared of x. I forgot what the other thing was. Hold on. Secant squared of sine of tangent of x dx. Sine of tangent of x dx. Okay. So that's an indefinite integral, but do you see an inside function that we could use a substitution for? Do you see something inside of parentheses?
Tan x.
Thank you, Aiden. U equals what? Tan x?
Tan x.
Of x. Okay, so then what's du going to be equal to? It must be secant squared x dx. Remember to put the dx when you're doing a differential du. It has to be a dx there, otherwise you can't fix this up. All right, so let's do some. Here's the problem. I'm going to replace tangent with u. I have secant squared of, I have this secant squared of x, right? Take that. I'm going to move it over here. Secant squared of x dx. I'm gonna replace that with what? Same thing, secant
D
squared.
du.
I'm gonna replace it with du. So what's the antiderivative of sine? Is it cosine or minus cosine? Is it positive or negative? That's the problem I have. What's the antiderivative of sine? What's the derivative of cosine? What's the derivative of cosine? Come on, you guys should know this. What's the derivative of cosine?
Negative sign.
Right, so that wouldn't be right. So what's the derivative of minus cosine? That would be positive sine. Okay. So that's the answer, but let's just ask, you can't leave the u in there. What was u equal to in this case? Tangent x. Okay. So that should be the answer, minus cosine of tangent of x. Let's see, is it minus cosine tangent of x? Okay. There's another way to do this if you're not sure. You could literally put all these functions into Desmos and see which one, if you take the derivative of it, gives you secant squared inside of tangent of x.
Professor, what happened to du in that? Like the secant squared x dx? Where did that go? And from line 38 to 39?
Okay, so here's the thing. The original problem, let me copy the original problem over, put it in there. So this was the original problem, just repeated, right? And you see, I have that u is tangent of x. So I can take this tangent and turn it into a u. But that secant squared and that dx, that I'm going to replace all of that is going to become du. Okay. So let me show you how I group this up.
So I think I understand that, but then from sine u du, you get the negative.
From there to there? Oh, because
Yeah.
that's the antiderivative. I'm just doing the antiderivative.
So the antiderivative of du is just c.
No. When you do the antiderivative of anything, integral of x squared, x squared. There's a dx there. Okay. It's part of the notation of antiderivative. It's a d, and I can
Oh, I see. I think I see what you're saying.
but that becomes x cubed all over 3 plus c.
Plus c.
There's
Okay.
there's no dx anymore.
So that applies to the du in this case?
Yep, the du went away because we found the antiderivative, and the answer has u's in it.
Okay.
Okay,
Thank you.
and then we have to make the answer have x's in it. No, that's a good question. Can I just say another way of thinking of this is the summation of x squared, okay, times, you know how the incremental difference is? We multiply it by, where'd that 8 come from?
Like n minus 1.
Right, you know how that we add them up if we're going between 0 and 1. Okay, we're adding up from whatever 0 to I don't know, so many n's, so I don't know, 10, 12. You're adding up the function, which is x squared, which would be n, which is, n. In this case, it would be 1 divided by 12 n. Right, so that's part of it. But then in the end, you multiply it by 1 over 12 so that you can get the area, basically. Remember when you add up a bunch of things, you add up the function, evaluate it at a bunch of points. And then you multiply it by the incremental difference, which is 1/12 here. That's sort of what you're doing here. Let me just see what this says. Yeah, you see how the answers are close? That's because we have too many of these. Hold on. Yeah, it doesn't matter, 12 or 11. We're just adding up a bunch of rectangles, but that dx, that differential, is sometimes thought as the incremental difference. Like it's so the x squared is like the height that you're adding up, and the dx is like the width.
And that is the incremental difference always going to be 1 over whatever n or whatever the top
No,
number is?
definitely it isn't. It's basically b minus a all over the number over n. So
Okay.
it might not be 1. I'm just going from 0 to 1. If I was going from 3, if I was going from 3 to 5, 3 to 5, then this would be 5 minus 3. All over the number of rectangles that we're doing, which in this case is 12. Okay.
It was like 1, 6 or something.
And this would be 2/12. And then, but you'd start off at 3, so it would be 3 plus, I mean, you have to do 3 plus, you're starting off at 3 plus 2/12. It's the same thing, it's actually the same number, 5 minus 3. Over 12. Over 12. See, it's close. It's not great, but it's close. You want more rectangles? You want 120 rectangles? 120 rectangles, then this would be over 120. And this would be over 120.
How about 1 billion triangles?
And by the way, see how it's a little high? It's really because it's supposed to be 119. You're supposed to do 1 less than what you want. So this should be 119. Sorry, hold on. What you want? 1 billion triangles? See, that's even better. 32. But how about not 1 billion? But how about 1 million? You want 1 billion? 1 million. Okay, then this number here has to be 1 million. This number here has to be 1 million. See how close it is now?
3 more zeros.
That's 1 million. You want 100 million? You're just being greedy now. See how it's shaped that more rectangles use. And by the way, this is supposed to be 1 less than that, but watch how little the number changes when I change it to 1 less than that. It doesn't change it at all because each rectangle is so thin. Each rectangle has this amazing height. Well, the height is like 3. You're adding up 1 million 3s, but you're multiplying it by something. It keeps getting smaller and smaller and smaller. So you might have 1 million 3s, but you have 1 millionth of a width. So they cancel out. Remember, infinity times 0, it's not where you're going. Anyway, so that's what that little dx comes from. But you can take advanced calculus.
So I can kind of think of it as like the incremental change, basically.
Yeah.
Okay. All right. Thank you.
Okay, very good. All right. That's the thing. So, all right. So this one, somebody got it, somebody missed it. What's the best candidate for substitutions? Okay, so U is the letter we use, but it's not what they mean. They mean for candidates, they mean what should you be looking for? And so remember I said, look at the parentheses, what's inside the parentheses. That's a good candidate for substitution. Anything that's in an exponent, that's a good candidate for substitution, and anything in a denominator. I say exponents and denominators because they don't generally have parentheses. So you wouldn't think to use them, but that's what you do. Okay. All right, who's going to say this for me? Who has not spoken yet? I've heard it. I have not. Heard Slade. Slade, read it to me.
Okay. You. Is that you? I can't see. Yeah.
All right, hold on, I'm
You-
gonna make it bigger. Hold on. Okay, I'm apparently not making it any bigger. I want to make it bigger. There we go.
Okay. Yeah.
Say the following. Boom, boom, boom. Right in the center of the screen. U equals. Keep
U
going.
equals A of X.
No. A to the X.
A to the X. Du equals A to the X natural log of A dx.
Perfect. Okay. Thank you, Slade. Any questions on that one? All right. That was 100% easy. So we're done with this. We're done with this quiz. I don't see anything else. Look, only so many people took this quiz. 7 people took it. And it ends tonight. So make sure you go on and take this quiz and do the best you can. Okay. Any other questions on this quiz? Again, I'll be opening this up and you can ask me more questions next week when we review for the final. Okay. All right, so that's quiz 10. Let me just, so in the announcements is where I put the project discussion. Project instructions. Greetings, calculus class. The moment has arrived, instructions on how to complete the project. Before you start any work, be sure you submitted your ideas. Did everyone submit their ideas in Mod 8? Hello?
Yeah.
Did I give you a grade for it that said 15?
Oh, let me check. I didn't see.
I might not have. Let me go into Mod 8 and see how we're doing here. Right. Mod 8 proposal, let's see what we got. Okay, Eric, what did you want to do? In this project, you're going to study Newton's method? No. You're going to use Python, solve some root? No. No, that would be a nice math major thing, but that's not what this project's about. It's about getting data in something you're interested in. Okay, let me stop for a second and talk to you about my conference that I went to last week. It's very interesting. So, in this conference that I went to, they were talking about AI and how students were using AI to whitewash their notes so they could, basically study a lot less rather than watch or listen to all the notes and listen to the teacher talk. They were just using AI, and it was synthesizing it down to little 15-minute blocks that they could, digest the whole lecture. The problem with that is, do you know what the difference between a 2-year school and a 4-year school is? Like, what's the difference between Mercer and Rutgers? Anybody?
I don't know.
Aiden, what do you think the difference between Rutgers and Mercer is?
Did you ask me?
Yeah.
The difference between well, there's plenty. There's a couple.
Okay. Tell me what you think the difference between education is.
The main difference for me would be that they offer 4-year versus 2-year.
Agreed. But what's the difference, though? Mercer sometimes they offer classes here for 4-year classes, but we're technically not allowed to, but Rutgers will come by here and teach them. But what's
the price? No, I'm not sure.
the price is certainly a thing. Okay, so let me tell you a little bit about me since I'm retiring. So I have a master's degree in chemistry and in mathematics. And I failed out of 2 doctorate programs. So sad, but I did know what being a doctorate in those things involves. And mostly you get your doctorate to make new knowledge and get your, and to do research. So what's the difference between Mercer? Mercer hires people like me who have master's degrees, but no doctorates. And I like teaching. Clearly, I'm passionate about teaching. But I don't do research in mathematics. So I give you as much as I can. Actually, I worked in industry. I liked that too. But I give you what I can to help you get a job or to I'm passionate about teaching. So I'm really into the whole learning thing, and I do a lot of data collection. But when you go to Rutgers, those teachers are not that great. I'm going to tell you right now, they're mostly terrible. The reason why they're mostly terrible is because the preparation for becoming a teacher at Rutgers is you get your doctorate. So you did all your research, you finish your doctorate, and then you go into you start doing research at Rutgers. They don't hire teachers at Rutgers as a rule. Now they do more now, but they don't hire the professors at Rutgers are not professors of teaching. They're not assessed on their teaching. Teaching is just a byproduct of what they do. They're actually researchers. You're paying all that extra money to be around. You just have to be around them. Be around these people who are excited about their field in hopes that you will be excited about that field too. That's what you're paying for. Okay, I wish I could give you excitement in mathematics. I do the best I can. But honestly, if I was doing research in mathematics,
I'm not excited.
Oh, good. But yes, well, I'm excited about mathematics, but that's why it's important that a professor have a positive attitude about the subject and like what they're doing. But you're paying for that at Rutgers. You hope to get a preference. And one of the things, AI can do your homework for you and get you that degree. But what are you going to do? If you had the choice of everything, of doing anything you wanted in the entire world, what would you want to do? And this is the problem. Yes, Jonathan, do you have an answer?
I was gonna say not work, but
There you go. So
That's a good one.
not have a job. Yes, well, that's sort of my dream too. But you want to be, if you want to work on something, if you could have anything in the world, do you want to sit around like those people in that movie? What was that movie? They were sitting on a cruise ship.
Wally.
Wally, wow, you really. I didn't think I'd give enough information for that, but yes, I was thinking about Wally. They were on that space cruise ship and they were just drinking and eating, doing nothing. Because everything was being done for them. But what would you do if everything you had could be done for you? And I'm going to say this, I hope, it's a problem that I'm seeing when I ask you guys to pick a project topic, you're having a real hard time just telling me things that you're interested in. I'm telling you, I've been doing this project thing for 20 years at least. And I've never had so many problems with students figuring out what they want to do. And also, I've never been, okay, and it's not just your fault. I'm not saying it's not your fault at all, actually, unless you willfully watch hours and hours of TikTok. Because TikTok is just, or any of those things, I'm happen to be a Facebook man, my Facebook, yes. Facebook. I get distracted. I go on to stay in touch with find out how my friends and family are doing. And all of a sudden I'm watching videos on kittens. I don't even like kittens. And I'm watching a video on kittens because they're so cute. And then and that kittens thing becomes, a woman putting her head inside an alligator's mouth. And I'm like, oh, I can't believe I'm watching this. And before I know it, I've spent 2 hours watching videos that I've basically that are only catching me incidentally and giving me, if I was looking at it from their perspective, they'd have no idea what I was interested in. And I think maybe you guys don't either, but it would be nice. What you're paying for when you go to Rutgers is somebody who's going to get you excited about the material. And if you're using AI to do that material, you're probably not interested in it. Okay, if you have to have AI synthesize the notes because you can't stand listening to the teacher, then that's not for you. And I wish they would update grading and semesters so that we could you could adapt to you guys more and just help you get excited about the subject. That's really the goal here, is to get excited about the subject. All right. So all I'm asking you is for something that you might be excited about so that we can collect data on it so that you can see how calculus can be used in anything you're interested in. But I feel like it's very difficult for people to tell me what they're interested in because you have so many possibilities. But let's try to narrow it down a bit. So Jonathan, yours is on the screen. The average price of a new car. Jonathan, you're going to get a new car?
No more.
What do you mean, no more?
I think I told you I've had 3 new cars this year.
No, that just means you love cars. You should sell cars. You know, that's the other thing about having a passion for something. If you like it enough to buy them, you can probably sell them.
Well, I don't have the patience to do that. I don't think I'm friendly enough to the public.
Oh, yeah, pretty friendly, but okay. After I said it, I thought I don't want to make Jonathan think that all he can do is be a car salesman. You can do
I
whatever-
didn't think that at all. Don't worry.
Okay, you can do whatever you want. But yeah, I understand that. So anyway, but new cars, that's fine. Okay, Selena, what are you doing? Yours on. Is Selena here? She's not here. But what is Cristiano Ronaldo's goal scoring efficiency? Oh, he must be an athlete. Does anyone know what he's an athlete of?
Soccer.
Probably. I can Google it. I clearly am not interested in soccer, but if that she is great. And if she's going to analyze his goal scoring efficiency, well, good for him. Good for her, I should say. Okay, Keisha, you're here. Really? You're going to track the number of ads played before a movie?
Yes, I guess so.
How are you going to do it? Are you just going to watch movies and see how many ads they...
I mean, I watch movie like a lot. I'm watching like sometimes the TV's on, and if I see a show that I'm interested in, I just watch it like all the time. So I guess I'll do that.
You could do that. You know what else is good? I think they over edit movies now. And if you watch old movies, they definitely didn't edit them hardly at all. But now, like I can't watch one of those Marvel things without getting a headache because they over edit them too much. Do you know what I'm talking about? Not for you, but you guys are young. You should enjoy that stuff. But for me, over editing gives me a headache. Yeah. And the other thing I don't like about, you're right about commercials and stuff. I have to record all my movies now because the last 2 minutes is all commercials. And you think there's a lot left to the movie, and it's really just 8 minutes of commercials and then 2 minutes of movie. But yeah, they do that all the time. All right, so Keisha, you could actually gather that data yourself. You don't need to look that up. You could just literally watch movies and see how long that. But you know what I would do? I would compare. Because the problem with the movies and the commercials is that has to, maybe at the time of day they put more commercials in, maybe the length of the movie. I don't know how they determined to put the ads in. It would be interesting to use data to find out what they were doing. So let me know how it turns out if you need any help. Alicia, what are you doing?
Book sales.
Are you into books? Are you a book reader?
I am.
What type of book do you like? You want this book?
I mainly read graphic novels.
That's comic. So why don't you do that? Comic book sales. No, they're graphic novels. Aren't they comic books? Aren't they really comic books?
Well, I tried to find like websites with specific data points with graphic novels and genres, but I couldn't find one that gave me numbers I could work with. But I did find a website with global book sales, so I decided to use that instead.
All right. I would guess if you were actually in the industry, you would be able to get the information from whatever data they have. So I'm sorry, you can't get that data. There are certain industries that are very possessive of their sales information. I don't know why. Maybe they don't want you to know how many comic books they sell because they become collectibles. And if you found out that there were 10 million copies made, you might be like, well, they're not that valuable. Do you know what I'm saying?
Yeah.
People collect them. All right, let's see what else we got. Slade. Okay, so clearly you like baseball.
Yeah.
Average runs scored by inning. You know what would be more interesting? Because there's 9 innings. Do you play baseball?
Yeah, I do.
Why don't you use your own data and see where your strongest innings are, if that's possible?
I might be able to.
The only reason I don't know how relevant this is because if you play, I don't know enough about baseball, but there are some positions where you bat first and some positions you bat last. And if
Yeah.
your team sucks, you might only bat on the third, even if you're good, you might bat only on the first inning and the third inning and the ninth, like sixth, like every third inning because because other people aren't pulling their weight. You know what I'm
Yeah.
saying?
Yeah.
So that's why, but anyway, that would be a reason to collect that data to see if you are playing in every inning and what your average score is at that of those innings. That would be something. But there'll be some innings where you won't have batted, so you won't have any data there.
Yeah.
But it would be very interesting to track your own data and see how you're doing and how the team is doing in relation to you. So, all right, I like it. Play on the Mercer team.
Yeah.
There's a guy in my online class who was on the Mercer team. I don't know if he still is, but anyway, it's in my online class. I don't think he's playing it.
Is his
What?
name Joshua Youngberg?
I do have a Joshua in my online class.
Yeah, because I know he said he was taking your class online.
I know. No, his name is Vincent something, and I think he was I don't think he's still at Mercer, but I don't know if he plays baseball anymore.
Mazzilli?
Yeah,
Yeah, I don't think he's at Mercer anymore.
no, he's at Mercer, but
He
he's in my
is?
class.
Oh.
I think he is but I think I think he's done playing, and he's
Yeah,
taking
yeah, he's not playing anymore.
right. You can't play for too long. I know he played several years ago, so I think he's done. Maybe he's at a 4-year school and he's just taking calculus here. People do that. I don't know his story, so I just know it's in my class. But I recognize him because he used to wear because embarrassingly enough, he works out at the same gym I do. So I saw him wearing his Mercer baseball clothes. So anyway. All right. Luke, do you have a hobby or interests that would be interesting? Because you didn't post anything.
Yeah, I was doing something music related.
Oh, okay. That's fine. Lots of numbers in music. All right. Anything else I can talk to you about? Do you need anyone else need any help with this? This is the time to ask because you have the entire Thanksgiving break or whatever to work on it. Actually, I suppose if you have problems on Tuesday, I could answer questions then too. But let me go back to the instructions that I had for you posted where. Oh. Okay, so. All right. So your ideas are mostly okay. I'll grade them, but I keep that open so you can keep changing them. Blank worksheet. So you know this. I almost wouldn't use the blank worksheet. If I were you, I would go right to the example worksheet. But you can use a blank worksheet. When you go to the example worksheet, this is the one we've been using all semester. It has everything in it that you need to do, the writer and the speaker for each one of them. So you just have to change the writer and the speaker to suit your problem. Okay, so you're going to go up here and you're going to go to introductory data and you're going to add some more data points. You have to add 9, that has to be 9, so that's 5. So maybe 30, 35, 40, 45. So that's what I'm expecting to see, 9 data points. Okay, I can turn the data on. I can make it zoomed in. So there's my data. All I did was add those data points. And then I might choose different limits of integration. I might 0 to 30 or something. Okay, and then I have the average rate change. There it is. Between 0 and 30, the average rate change is 40. So you have to do the writer part and you have to do the speaker part. Okay. And you're definitely going to have to present that average rate of change. I'm always looking to, I want to know what the average rate of change is and between where and where. Then there's a limit. You can do an inner limit or outer limit. All you have to do is pick a value that you're interested in. Looks to me that, let me see, 30 is B1. So at 30, it looks like you're at 12, you're at mile 12. You can also have to change these, the graph, whatever you're doing your data on. Okay, and then you're going to write it as in limit. That's the writer's going to write it as a limit, and the speaker's going to write it in words. All right, then you go to polynomial, derivatives. This is already done for you. So all you have to do is write it. Transcendental, the transcendental one, you might have to change your sign regression, your period of your sign regression. I don't think you do here. You just leave it. I mean, especially if that's the data, it's okay. It's as good as you're going to get. Mean value theorem. Oh, remember that when you're using the sign regression, you have to know the period. So you have to figure out if this is minus 68 and that's 52. It's 52 and 32 is 84. So this period here is 84. Which is weird because it should have been 120. Oh, that's what it is. I'm sorry, 51. No, it's not 120. We have to say the period. Mean value theorem. You could do a mean value. Remember the mean value theorem thing. Let me turn this other stuff on. For the mean value theorem. Hold on. Remember, you do the derivative and average rate of change, and you find out when they're equal to each other. That would be like here at 33.88, and then you have to put that in here. 33.88, and they have to be the same. So the average rate of change is equal to instantaneous rate of change at 33.88. Okay. There's another one over here. 11 point something, like 11.2. And you could turn that average rate of change thing on. So that's the average rate of change. And if you change this to 11.02, Okay. And then turn the circle on. There you go, tangent line. See how they're parallel? Same thing with you if you put 33.88. Those are also parallel, but if you pick a different number like 25, not parallel. Okay. So you can see that it goes parallel there. So that's at 11, and it's parallel again at 33.88. Okay. Actually, 33.88 is not an answer because we only go from 0 to 30. So I'm just eliminating 33.88. 11 is the only one we care about. Being values here. All right, error. You have to make a prediction of error. Okay, where am I going to be at the 31st hour? So 31, I'm going to be at 1260 plus or minus 17, and that represents a 1.4% error. Analysis of functions. This is probably the hardest one. You need to make sure that your graph, let me get rid of all these other graphs. Stop that from moving. You need to make sure that your graph, this guy right here, see, so this is a problem. This graph, does it have a max, a min, or an inflection point? If you're going with this graph, okay, who's new to this thing? Christian. Oh, Christian's in the other class. Jonathan. Does this have a max or min? Yes or no?
No.
No. It does not.
No. Oh,
It
sorry.
does not have a max or min. It has to go like a parabola, go up or down. Does it have an inflection point? And where might that be? Aiden, were you the one who was talking to me?
Yeah, it looks like it could around like 25, maybe.
Yeah. So all you have to do to find the inflection point is to do what?
Find when the second derivative is 0.
Right. So for analysis of functions, you just have to do y double prime with x equals 0. Uh-oh. How about f double? Uh-oh. What are we calling this function up here? F of x. Yeah, why isn't it working? Maybe there's more than one f of x. Oh no, there it is. Oh, there it is. So the answer is 22.45. That's where the inflection point is, right there. Okay, that's fine. That doesn't, that's an inflection point. You have to make sure you put that in there, 22.45. But guess what? Since there's no max or min, you have to do another regression. You know which one does have a max or min for sure? That you don't have to redo is the sine regression. You can find a maximum right here. 51 point whatever. Sine regression is called g of x. So you would go down to your table and make sure you put in g of, that's error. Okay, so yeah, you have to tell me that g of x, you want to know what g prime of x equals 0. Okay, and so the answers are going to be here at wherever that is, 52. And there's another one here at whatever, but you could just say 52. Okay, so you have to make sure that you have an answer that has a max or min in it at an inflection point. Just sine regression and everything else. Okay, that's why it's hard, because you might have to change the regression using right now. This only has a quartic regression. Wait, there's a quartic regression. That should have a max or min, right? Hold on, why am I making it harder on this now? Let me turn that sign regression off. Quarter regression definitely has a maximum, right? I don't see a maximum. There should be one. Why is there no maximum? Oh, there it is. It's way down here. I can't even, it's somewhere in the negative there to there. Let me see where it's negative 50,000. So I'm just going to take my x-axis, go negative 50,000. About 20,000. I'm going to predict the y value, sneak it bigger, 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 take. Uh-oh. Got so big I can't see it, but there's a minimum there somewhere. Let me go back to that. Take out some of those nines. Right. What happened here? Right, there's a minimum right there. Minus 30. So if you're giving a talk and you're telling me the minimum is at minus 35,000 and this is something like how far you've traveled, that minimum makes that makes no sense at all. I'd rather you do the sign regression. Because I don't get it. All right, and then we went over area and average value for that. It's pretty much automatically done already. You just have to do the writer and the speaker. And then approximate area, you just have to make sure you mention the number of rectangles that you're using. And make sure you say it. I'd write it the right way. See, here it is with all the A's and the B ones. Don't leave me A1s and B1s. Make sure you write as a writer, you actually write out that summation stuff. Okay. All right, so that's what I think you're going to do. That's easier is to go to the worksheet, the one that's already done. Okay, now once you're finished with that, I want you to post your worksheet. It doesn't have to be perfect. It's not going to be graded, but post it and then let 2 people look at it. And then you look at 2 people's and give them feedback. Okay, you'll be getting a grade for giving feedback and they'll be getting a grade for giving you feedback. Okay. So make sure you do it. I expect there to be 4 in your posting. There will be you'll have yeah. Show me the 2 that you posted, and that'll be part of your grade. All right. Again, I said make sure as a read when you're evaluating them, you're just basically telling them if it's interesting, relevant, informative. Don't do any math. You shouldn't have to do any math. Check to see if their math is right. Okay.
Professor,
Yes.
I see on the directions it says that we need 9 data points. On the like the data I found from my project, I only found 6 data points.
Well, what's your data? Books?
Yeah.
Find 3 more.
Okay. I'm kind of struggling to find a website with like concrete data, but I'll try to find something.
And it doesn't have to be if you have the last 6 years, you don't have to do the last 3 years before that. You could do decades, you could do the 70s and the 80s and whatever. You could go back further. Okay. So yeah, sorry, but you should be able to find I want 9 data points. There's a few reasons why I want 9 data points. One is because the old calculator used to max out at 9 data points, where that's all you could see on the screen at a time. But that's not really why I want 9 data points. Really, the main reason I want 9 data points is because okay, this is what stock market data looks like. It's all jaggedy and stuff. That's because there's lots of data points that make it look that way. If you only have a few data points and you do a regression, you're only going to get like a parabola or whatever. You can't get a high level polynomial. But if I were looking at this data, let's say, I might want to fit it to a curve that has 1 face, 2 face, 3 face, 4 face, 5, 6, 7, 8, 9, 10, 11, 12. So if I set it to a polynomial of degree 12, I might get a polynomial that looks kind of like that. But if I only use a few data points, it would have to be a parabola or a line. So I need more data points. The whole point of this is for you to see how calculus can be used in the real world. And real data looks ugly. Okay. So get some ugly data if you don't mind. Okay, this right here, this is my world when I was growing up. This is what mathematicians do. We didn't have good things for real data, so all we would have is simple curves. Okay. But you can do better. We can have higher degree polynomials and stuff. Let me see. All right. I think that's that. I think that's, let me see, is there anything else I need to cover that? Any other questions on this? So it says the entire project is due by the 7th. Entire project submission is due by the 7th. Okay, that's interesting. The reason why I want it due on the 7th is because we have class on the, I would like on the 7th is a Tuesday. I would like, or the 9th. What? Am I looking? That's January. I would like it on the 7th. I would like to be able to see them on the 10th. I'll accept them later, but I want to see them for the 10th, and you won't be able to get people to review your stuff, and you'll lose points if you don't hand it in earlier. So 10th is when I want the videos so I can show people. It says the 7th, but try to get them submitted by the 7th so that people can give you their feedback. Okay? Anyway, work on it. Just work on the spreadsheet this week. And then we can talk about it some more when we get back. Any other questions? All right, I don't want to cover a lot of new material or anything because you're just going to forget everything I say. So I think I will let you go. And since you did commute, none of you drove all the way over here in the pouring rain. You won't mind if I let you go. Okay. Any questions before I let you go? Going once? Going twice?
Maybe just a quick suggestion because I'm still having trouble thinking of an idea. Maybe like if you could just point me in a direction to
Okay.
research like an idea.
Sure. What can I help you with? Oh, you want to hang around? I'll let other people go and then we can talk.
All right.
Okay. Anyone else? Anyone doesn't want to hang around? You can go.
Good night.
Good night. Have a good night. Anyway, Aiden, I'll be right back. I gotta right back. Over.
All right.
Everyone can go, but Aiden or anyone who has questions. Okay, Ethan, I'm back.
Okay.
You
Yeah.
have any problem finding a topic?
Yeah, I think I just thought of one.